6. Well, you have to look at it like this. This is the first toss. This is the second toss, the third toss, right? So all three of these together make up the 3 flips, right? There are 8 different possibilities, like combinations, right? We can get a heads on the first toss, we can get a tails on the second toss, and then a heads on the third toss. So this triplet represents one outcome of flipping it 3 times. Yeah? Okay, so there's 8 different paths. Exactly, right. So all of these are connected. So you're looking for the paths that have exactly 2 tails. Yeah? Well, out of 8, right? Because you count the number at the bottom, there's 8 of them. Yeah. Hold on.
So just the same thing, but over.
Yeah, same thing.
We know. How do we know it's independent?
Okay, it doesn't say it, so you can't assume it. Okay, so you do the general formula.
Oh, the
The general one over there, right? And you have all 3 of the elements you need for that one. Cool.
For number 6, would it be that it's under the condition that C and D are independent? Is that like that?
Let's see. Yeah, you can. That's one condition. Yeah.
Well, what's like the main point?
Um,
Or is there like a main point to the question? I don't know.
Yeah. So the hint says to use the conditional probability. So it says to rewrite C given D as C and D over D,
So they're all greater than 0.
and then write the other one the same way,
Under what conditions?
and then equal both of those, and then something needs to happen right there.
Okay.
So you see what I mean?
I mean, I'll start, like, I'll do the equation and see
Oh,
if I
you
get
just it just came to independence.
it. Yeah, I don't know.
Let's see, you get C and D over D.
So you're saying
Yeah, yeah, you can. Independence does work.
one of these?
It does work. Sorry. Yeah.
Is independent the answer for number 6? It's like under what conditions? I remember in lecture him saying like if they both had a 1/2 chance of occurring, then you could say they were independent,
Okay, what
regardless
I
of
wanted
which
to
one
say
went
is
first.
that it will happen when PC equals PD.
Yeah,
Is that the answer?
that's
Like,
it.
It's independent. Am I right?
You can do independence. You can do. They all work. Those 2 work.
See, haha.
Because when you rewrite this with independence, you get probability of A and B, and then the B's cancel, and the other one you get the A's cancel.
So this.
Yeah.
Yeah.
Eventually, with independence, you will arrive there too. You all done? You all done, Stephen?
Yep. Oh, I need to put my name in it.
And I should get a huge box of donuts.
Awesome. All right, have a good one. Yes. Blue books, guys. Blue books, blue books.
I've given you.
My backpack is in my friend's room locked up, but I do have them.
Yeah. Cool.
So can we?
You can book it.
I have the formula for this, but I don't get how to get that.
Okay, remember I went over that?
Oh. Oh.
Yeah?
Right there.
Hold on.
This says, I don't know how to use conditional probability. The definition of conditional probability is to prove that
Okay.
P probability of C given D is probability of D given C.
Okay. So you rewrote them, right? As this. Okay, notice the top of these fractions are the same,
Yeah, I know this is.
right?
Yeah.
So the only way these two fractions can be equal is if the bottoms are also the same,
So it's
right? So what does that mean? That means P of D should equal P of C.
Like P and C is everything but A, right?
That's the condition. What?
One minus
Like
B under what condition?
when? Yeah. When does this happen? When these two are equal.
So that's all you need.
That's it. Yeah. Yeah, just put your name on it. So, have a question?
So PAC is that one, but PA is also that? Or
Well,
no?
PA is 1 minus P of AC. So you just switch the A's and the AC.
It's asking what condition
Like given that B happens,
Right.
right?
Okay, so there's a general formula for all these conditional probabilities. Remember?
That you just gave us?
Yeah. So it's yes. So A and B over
Oh, okay.
B. Yeah.
Sorry, yeah.
And then the other one you just switch them.
Thank you.
And then here it doesn't matter.
You said you arrived there correctly.
You do.
When you said about like drawing the thing, what does it mean? Like, is that it wouldn't even matter if it was like
What do you mean?
Hmm.
Okay, so you want these two to be equal, right?
Yeah.
Okay, the question is when are these two equal, right? Okay, so you have these two fractions. The top of this fraction is the same as the top of this fraction, right? So the only way those two things are equal is if the bottoms are also equal,
Oh, I see what you're saying.
right?
And then it would be like P of C.
Yeah, and then they would be identical,
When they're
right? When they're the same. Yeah,
got it. Okay. Thank you.
you're welcome. What's up?
But I'm trying to figure out everything except for 1 minus P of I, right?
Yeah, so you're gonna have complement here, right? And here. So here you would substitute 1 minus P of A.
Oh, that's it?
Yeah. But here, that's where the difficulty will come in. This is where you're gonna have trouble with the. You're on part C, right? Yeah. So this is 1 minus A, B, and then A complement and B, right? And I worked that out on that side to start the class. Remember? Okay. So A complement and B, right? Yeah. Right. So that's just the and part. That's just the and part, right? That's just this part, right? So I don't understand your question.
So, in the rightmost section, the P of A complement and B, to solve that, if we don't have A complement, we plug in 1 minus P of A.
No, no. So you don't know this, right? Okay, so to find this, you gotta draw the picture like I did over there, right? So so can you see this, Krista? Yeah. Or I'll redo it over here. So this is A and this is B. Yeah.
So all of B plus all of A except the middle class.
Sort of. It's all of B minus the part of B that has to do with A. Yeah? So it's this part right here. Okay. So this is.
It's always so hard until you get to the point where
What did we cover that?
It's not 1 minus P of P probability of A plus probability of A and B.
Because this is what I'd like. Let me see a picture.
You might end up at the same.
Yeah, it might be the same thing.
You get 7 12.
Yes, I did.
Yeah, that's fine.
Is it?
Yeah,
Is it?
because this is right.
I don't know where it is.
And I just put Tuesday because I missed it.
Okay. Thank you. Yeah, it's the same thing. Yeah, because this is A complement, and so watch. This is A complement, and what you see here is you're going to subtract.